The magnificent moves of the aurora, or northern lights. They can be seen over the far northern regions of the world and at the South Pole. And sometimes the beautiful sheets of color move about the sky in wavy patterns or bursts of brightness. But besides sparking the awe and fascination of people lucky enough to see them, the celestial dances of the auroras have provoked a decades-long debate among scientists. Exactly how and where are they being triggered? The question has confounded space scientists for more than 30 years. The sun is continuously shooting off electrically charged gas called solar wind, which blows forcefully across the Earth. Some of the charged particles get caught in the magnetic field that surrounds the Earth, the magnetosphere, stretching it out like rubber bands and showing up as an aurora. Very strong solar winds cause space storms and stress the bands of the magnetosphere, triggering a sudden release of energy called a substorm, stirring the aurora into motion.
Okay, you can see a bit of aurora through the clouds at one of the sites.
UC Berkeley Space Sciences Laboratory is leading a NASA mission to finally understand how and where auroral substorms happen.
This choice of putting together a mission that will study this very focused goal was a combination of the field reaching that level of technical expertise and a nagging question that the field had to resolve.
0 to 7. If we go 0 to 7.
Vasilis Angelopoulos is the principal investigator of the mission, which is called THEMIS, after the Greek goddess of justice. Justice in this case being the final ruling on where auroral substorms are triggered. Aside from greatly broadening our understanding of space, the new knowledge will also help scientists protect astronauts and spacecraft from getting hurt in violent space weather.
It is a fantastic opportunity for Berkeley, but it also is a tremendous responsibility. So it has been exhilarating, but also excruciating, but great fun.
Berkeley's proposal for THEMIS beat out 70 other mission proposals when NASA put out a call for its Explorer program. As a collaboration among NASA, Berkeley, UCLA, and space science agencies and universities in Canada, France, Germany, and Austria, THEMIS is a new kind of space mission in many ways. It's a constellation mission, meaning several satellites will be launched together in one rocket and then released into separate but specifically designed orbits.
The THEMIS satellites are designed to be placed strategically along the Sun-Earth line and track the flow of energy from one to the other, very much like meteorologists use buoys out in the ocean to track large ocean waves as they move from one buoy to the other in order to understand the flow of atmospheric energy.
Berkeley built the instruments for the 5 satellites at the same time, also a first, and will be controlling the route and choreography of the spacecraft throughout the mission.
Everybody says you can't get 5 spacecraft done in that span of time, and we did it anyway. You know, we weren't making hot rods. We were making, we were making Tauruses. We were making Volkswagens. We knew what they needed to be able to do, and so we built that in early, and we built it so that they were easy to manufacture, easy to put together, and easy to test.
Well, THEMIS has been challenging because we have 5 spacecraft to build. It's important that they all measure basically the same magnetic fields and electric fields and particles.
At a cost of $180 million over 3 years, it was a real achievement that the THEMIS project came in on time and on budget. NASA's Dave Sybeck says the investment on THEMIS has been well worth it.
This is absolutely the greatest thing that's happened. We're going to have all the information we need to address the questions that have been raised over the past 30 years.
One of the key ways the THEMIS satellites will answer the substorm question is through their long antennas, which detect electrical and magnetic fields during substorms.
And this is what's known as an axial boom. One shoots out the top, one shoots out the bottom. This thing deploys in about half a second. It was nicknamed the death spike by our illustrious spacecraft contractor.
To complement the satellites, scientists at the University of Calgary installed and operate 16 observatories in Canada. The stations are equipped with fisheye cameras and computers built by Berkeley that photograph and record information about the auroras passing over them. Berkeley runs several more stations in Alaska.
The dome protects the lens and the camera from the elements, and they have temperature control so that these little boxes can survive and take the data down and transmit some of the data back to us more or less in real time.
THEMIS also has a strong public education component directed by Berkeley's Center for Science Education. UCLA installed magnetometers on 13 remote rural school campuses in 10 states where the instruments can register changes in the Earth's magnetosphere free from interference from traffic.
The THEMIS mission will be complete in 2 years, but if all goes well, the scientists here expect to redirect the satellites to explore other unanswered questions about space. At Berkeley's Space Science Laboratory, this is Roxanne Makascha.